Hello everyone, this is the SMC Journal Podcast. I'm Scott Moore, your host. This show is all about performance in IT today. Yes, I have guitars and guitars. This is not a show about guitars, although that would be cool too. But no, we talk about performance testing, tuning, monitoring, optimization, all those good things in IT. And today's show is all about profiling databases while under load or during a load test. Let me talk a little bit about that. You know, if you do any load testing with any products and you're adding monitoring, probably monitoring the basic infrastructure pieces, CPU, memory, disk, network. If you're monitoring a database as part of this application, you may be even able to get additional metrics. Let's say you were monitoring SQL Server, there's additional performance monitors just for that. However, there is a deeper layer usually obtained by database administrators called profiling information, and that's today's subject today. I'm going to interview a couple of friends of mine, and we're going to talk about the importance of should we be gathering that level of detail from a database, the profiling information while under load, and is there a product that can help us do that? Before we do that, let's talk about our sponsors today, and that includes my friends at Micro Focus, the makers of LoadRunner Professional, Enterprise, Cloud, and Developer. Performance matters, and LoadRunner has the largest set of practitioners in the community, which you can check out at community.microfocus.com. You can also look at their LoadRunner family page and YouTube playlist by scanning that QR code that's on your list. We're also sponsored by Keysight Technologies, the owner of Eggplant software. Now, Eggplant makes Eggplant Performance, and that is a load testing product that supports web, Citrix, and low-level TCP/IP protocols to help you meet your application performance testing needs. It also has real-time monitoring and integrated test analysis results. You can check out more at eggplantsoftware.com or scanning that QR code as well. And both of these products that are sponsoring our show today are products where you would get this level of monitoring around the infrastructure, as well as pulling in specific database specific metrics, but not profiling information. And up until now, that's been very difficult to get unless you were also had the DBA tool, or you were a DBA and you had access to that information. It's not as easy to integrate that or create some kind of a snapshot that says, I've run a load test, I want to know just that profiling information for this period of time while it was under load, because it is a lot of detail. But let's get into our interview today and we'll talk all about it. Well, we've got James Pulley and Mick McGuinness on the SMC Journal podcast today. Welcome, my friends. I'm going to basically do a small intro for each of you, and then you can kind of expand on that if you want to. James Pulley, I think you and I are probably on screen together more than any two people. We're kind of like the Jerry Lewis and Dean Martin of performance testing, I think. But James is the Chief Performance Officer. I'm not saying that you're Jerry Lewis. I'll be Jerry Lewis, okay? So
you were anticipating my question.
Yes. You're the alcoholic. No, it's fine. James is the Chief Performance Officer of QA Consultants, and is building a really cool performance engineering practice for their U.S. firm. Mick McGuinness is with DBMarlin, and this is a vendor that Scott Moore Consulting is partners with, and also James Pulley and QAC are also partners and users of DBMarlin. So we all know each other, we all love each other, and we love each other's services and products. So today we really just wanted to get together and talk some shop. I want to really talk about why it's important to monitor the database even at a granular level under a load test, and why load testing or performance engineers and load testers should be having a view to this, because the biggest thing I've seen at probably 60% of the customers I've consulted with in the past have zero monitoring. They provide load during a load test, they get an end user transaction time, and zero visibility into the infrastructure. They're not even looking at the basic infrastructure metrics like CPU, memory, disk, and network. But it goes beyond that. There are additional counters that we should be looking on specific pieces of the infrastructure, and the database is probably one of the most important ones. And that's an area that traditionally has been disconnected from the performance tester, because they're kind of told sometime in some companies, hey, you just run the test, we'll look at all that cool stuff on the back end, and then we'll figure it all out. You just provide us with the load that we need. And one of those things is when you're dealing with a DBA, they're probably looking at some kind of a profiling tool under load, and that kind of tells them, hey, we missed some indexes, we missed these things, and that tells them kind of what's wrong. So I'm kind of wanting to know from your experience, James and Mick, is that your experience as well, which is they're not doing any monitoring, but they're definitely not getting that deep, right?
Yeah, monitoring is a problem across the industry. And in fact, we have a whole class of performance testing tools that don't support monitoring at all. And these are growing in popularity. There are many reasons for that, but ultimately it is because people who are being asked to do performance tests do not understand what drives performance, is how resources are being used. And this has been known in the database community for a long time. This is the whole reason why we have normal forms in databases, to improve performance, to reduce scan time on, to make indexes shorter, to improve how, to reduce both storage requirements and pick up speed in the database. And it's tragic that this database analysis using profiling tools is kind of hidden behind the scenes in many engagements, because profiling as a concept is something that we use every day in performance, whether we're profiling the cost of requests at the web tier, whether we are profiling the cost of code using tools like New Relic or Dynatrace or X. Those same concepts apply. What is the tallest fence pole that needs to be cut down, which is the longest running query, which usually has the highest resource dependencies? That is, it's missing an index, so it's doing table scans. It's got the longest lock on the table because it has to update the maximum number of rows. There are any number of reasons for it, but ultimately, if we have a promiscuous user on the system, all the other users have to wait until they're done using those resources. And so that's why it's critical to look at data storage and how efficiently that is being used. Mick?
Mick, on your side, isn't that the reason, this question that I've asked about people not doing monitoring, isn't that the reason for the existence of DBMarlin, is what you've seen in the market?
Yeah, definitely a big part of it. So yeah, I would agree with what yourself and James said, that monitoring during performance testing is not always there. In some cases, there is no monitoring other than what the performance testing tool is giving in terms of transaction response times. And yeah, really, you at least need to be monitoring the basics, CPU, disk I/O. Those are obviously critical factors for database performance. But with databases, you really need to go beyond that as well, because there are all kinds of things that can affect database performance, other than just the CPU being maxed out or the disk I/O being maxed out. There's databases have all kinds of locks and latches that control various different things, and you can get all kinds of different wait events. With our product, we track over 1,000 different wait events across all the databases that we support, and any of these can be the source of contention. So you really need to go beyond even just CPU and disk I/O. You need to kind of look at specifics for database monitoring, and with DBMarlin, we kind of built it to cover all of that for production, but we've also added a lot of capabilities for performance testing that we think are really important as well.
You kind of hit the nail on the head on where I was going to go with this, because we talked about no monitoring being done. But let's say that, okay, so I'm familiar with LoadRunner, NeoLoad, a couple of other tools where they have monitoring capabilities, at least the basics. And what they traditionally do is, let's say you were using LoadRunner to monitor a Windows system, you would tap into the existing performance monitor feature that's built into every Windows operating system. We would call it Perfmon for short. Us performance geeks, insiders, we know it's Perfmon. And then if you're wanting to monitor a Unix or Linux-based system, you would use some kind of a rstat-d or something to that effect, VMstat. You would basically, it's behind the scenes scraping this information, it's pulling it in, it's putting data points in. All right, that gets you like halfway there, but now maybe you find out that after doing that, oh, it is the database that is crumbling under load. Now you need that new level of information. Well, in Windows, if you were using SQL Server, there's a Perfmon counters that are specifically for SQL Server that would only exist on that SQL Server machine because you had installed them at the time you installed SQL Server. In other words, Microsoft installs those libraries when you install SQL Server. But that's not the end of it either. There's another level beyond that, and I think this is where DBMarlin plays a role, where if we're still sticking with SQL Server, a DBA would open up what's called SQL Profiler, and they would look at more information there. That is something that has not been privy to the load tester with traditional load testing tools alone. It would have to be something that was an add-on or some kind of other, some over the profiler that has a lot of overhead to it as well. This is something DBMarlin is trying to give the load testing community. Even if you don't have a tool that's monitoring the basics, you can still get to that. Is that right?
Yeah. So the Perfmon counters and the equivalent on Linux that you mentioned, DBMarlin can capture those metrics as well, and those can be useful in getting to the root cause of issues. But actually, you kind of need to start with, but they're kind of at the instance level. They'll tell you how the instance is performing overall, but you kind of need to go deeper than that. So you need to be looking at individual SQL statements. What are the top statements? What are those statements doing? As in, what are they waiting on? So we kind of take a time-based approach. So we look at how much time is spent in the database executing, and then we break it down by all kinds of different things. So break it down by statement, which statement used the most database time, which wait event contributed most to the database time, and then we can go deeper and deeper and deeper. Keep drilling down. Which user, program, session, all those kinds of things. So it's really kind of taking that time-based approach and then allowing you to segment that however you want to find out what the top source of your problem is. And the counters on their own, they can be helpful in once you've kind of understood that, okay, most of my database time is spent here, then those metrics can be useful in helping you get to the root cause. Some cache is undersized or whatever. But I would always start from how much time am I spending in my database? Where's that time being spent? And then use the counters as a secondary thing to help diagnose the problem.
James, I don't know about you, but I would say a good 60% of the main bottlenecks I find in traditional in-tier web-based and even desktop apps from back in the day, 60% of the problems were the database, and it generally was low-hanging fruit. And it went something like, hey, we're running a load test and we have the whole team watching that for the back-end systems. The DBA is watching that SQL profiler and says, hold it just a second, stop the test. They make a few quick changes, you rerun the test, and all of a sudden everything is so much better. And you're like, what did you do? And then you have to document what they did. And it was generally fixing something that would only be seen under load. But it was very common, and it amounted to about 60% of the problems with those applications. And that's just my experience, but does that match with yours, James, at all?
This is where we have two or more users running in anger. And this is the only time we begin to start contending on resources. So we might have a long-running query in the database that's not supported by an index, but if it's running on its own, it might be okay. As soon as we add a second and a third and a fourth that now are contending for access to the disk arm to read and table scan the data again, we now have this concept of a wait. We have a lock wait or read wait or some other type of wait in the system, and that's leading to the degradation. That's leading to the inefficiency there. And Scott, to your example of the database administrator saying, hold on, let me fix something. It could be that they added an index. It could be that they changed a SQL statement in such a way so it took advantage of an index. It could be that it reduced the scope, subquery. But in all cases, it's improving the efficiency of that query. So it takes less time So all of the lock weights and latches that are in the system have a smaller window of opportunity. So that means they free up faster. That means the next person in line to get that lock or latch is there and is able to grab it, and they're holding it for a smaller period of time. And this is why when you take the worst performing query and you improve it, it improves not only that query, but the entire system, because the resource dependencies for all of the other can now be satisfied on a better basis.
So I think we've established so far what it's important to, number one, have monitoring going while you're doing load testing. And I would hope in 2022 that people got that. I'm not sure that they have, but it's also we've established that when you're dealing with a database, especially the major relational databases out there, we need to be able to go deeper. And I, as a load tester, don't want to be limited. I want that profiling information as well. I want it to follow me from load test to load test, and I want to know each load test, what were those numbers, so I can compare them as well. And that's not a lot. A lot of load testing tools do not provide that to me. So this is why I love DBMarlin. So we've got a slide here that talks about the top 5 reasons why it's important to monitor at that level under load. I'm going to bring that up right now, and I just want us to kind of talk to that. So the first one is, if you do this, you will understand your database performance baseline. And so I think we've kind of established that as being really important from the beginning. But is this something, Mick, DBMarlin kind of has that built into it as well, that you have a way to get a baseline and save off that baseline, right?
That's right. Yeah. So we keep the data. First of all, we keep it at high granularity. So 1 second granularity on the data, which is really good for load testing, because load tests generally run for a short period of time. So you're not interested in looking over longer periods, but over a short period having that detailed data. But then what we allow people to do is to save that data. Most monitoring tools out there data will just kind of age out, and it will get rolled up to hourly aggregated or daily aggregated and eventually purged. But what we decided was, particularly for the performance test use case, it's important to keep that granularity until that data is no longer useful. You can save it off at the maximum granularity, then you can always compare back against that baseline.
The next one would be spotting performance bottlenecks, and I think that's what we've been talking about for the last 15 minutes, which is if you monitor your database, you can't fix what you can't see. This allows you to see it in a better way. So that's established. The next one is if you do this, you can track the impact of changes made to resolve bottlenecks. So this one's really important, and James, I want to get your feedback on this, is to be able to say, we want to start a trend line because we're moving towards continuous performance. We want to be able to run a test, especially if we're in a tuning engagement. There's a small incremental changes that are being made. I know of one client that I was working with where they were making like 1 change a day, and over time they wanted to see how those changes were benefiting or not benefiting the database performance. And sometimes it was good, sometimes it was bad, but to be able to see that, how important is that to the engagements that you're doing right now with QAC, James?
Ultimately, that is the end goal. You want a beneficial change, and you want to be able to demonstrate that objectively. Any tool that is going to be able to do that from the client experience all the way to the back end is going to be beneficial. Ultimately, you want to have a beneficial change at the real user monitor level for the end client, but that has to be reflected changes throughout the system. That is, reduce load on the web tier, reduce load on any app servers, and a reduced load at the database level. That becomes even more critical when you move to the cloud, where you're paying for bytes used, CPU nature. Efficiency is rewarded in the cloud. On the other hand, I think that many cloud providers would be happy with very inefficient code because that means you get a bigger cloud bill.
Exactly. This kind of goes along with the next one, goes along with it, keeping a history of performance over time. maybe this is tracking performance not because there are these small incremental tuning changes, but what happens when patches come out? I'm thinking of a couple of packaged applications right now that if you don't track when patch 42BC131, when that was applied 2 months ago, it was actually affecting something, and over time it just causes this really slow memory leak or something. Like, I can't tell you how many times people have gotten in trouble with that because they weren't looking at this trend line over time, and that's something that's very important too. This is also something.
Do you remember what happened when Intel had a microcode patch that impacted virtual machine performance in the cloud, and all of a sudden performance degraded for everything?
Every single person using that chipset.
Yeah, so everyone should be monitoring. So if you apply that patch, or that patch gets applied in the background, and all of a sudden your performance decreases, you should be able to answer the why. And ultimately, that's our value proposition for performance testing, performance engineering. It's not the what. That is, okay, everybody knows it's slow. That's easy question. It's the why is it slow, and then the complement to that is how to make it faster, and then once that is applied, how do you measure the improvement?
And the last one is being able to compare load test with production. And I think I'm actually doing another podcast on the top 5 reasons why load testing doesn't work well in organizations. And one of them has to do with environments, because we don't have an environment that's anything like production ever when we go into, and it's becoming easier when it's container based and you can spin up an environment that's equal for a specific period of time. But it's very expensive to have an environment that matches production. So when people are building environments that are less, they need to be documenting, hey, if we're going to build 10% of production, we know it's 10% of production if it's too expensive to build, but we also need to compare that environment we're testing in to production. The only danger I see, and help me with this, James, is just because somebody says, well, if it takes less than 10 seconds on this environment, it's going to be really fast in production. Not necessarily so, only if the configurations are exactly right. I mean, you run into that as well?
I do, and of course, there's always this issue of data volume changes in production as well. There are issues that you may not see on a smaller scale system. Let's say I have a smaller scale in terms of data as well as processing power. I still might wind up with tables all pinned in RAM by the database management system. So even scans and locks are really fast when they happen in memory and they don't have to go through a disk subsystem. Even an SSD is orders of magnitude slower than physical system memory. So you can hide performance issues by having smaller systems and smaller data sets that for issues that only show up in production with larger data sets.
I know that, Mick, these things we talked about, the things that are important and why you want to do it. These are things that DBMarlin has tried to solve for the load testing and performance engineer community. Let's go to the top features that you've built into DBMarlin to address this. Can you walk us through this list of these features and how they will help us to get this information that we want?
Yeah, sure. So starting from the top, so we work across multiple different database types. We're supporting 7 different relational databases right now: Oracle SQL Server, Postgres, MySQL, IBM DB2, Cockroach, and MariaDB. And we work with those both in the cloud and self-hosted as well. So that gives us pretty wide coverage. I mean, that's probably, again, to quote, maybe 60% or even more of all the databases out there. Obviously, there's a lot of databases, but I think those big ones there that I just mentioned probably cover the majority of them. And so what we've done there is we've give you a common UI, across all of them. So these days, more and more companies are in a kind of heterogeneous environment where they don't just have all of the data sitting in one database platform. They'll have a mixture. So by giving a common interface where you can look at performance across any of those, that's one of the big things that from the start we wanted to do with DBMarlin, especially where you've got organizations where they don't have a dedicated DBA like we were talking about earlier, and it's maybe performance engineers or developers who need to access this data. just make it as simple as possible for them to kind of look across all these database types and make the information easily digestible, was one of the big goals from the start.
Mick, you just made the value proposition statement for about every enterprise tool that's been sold in the last 2 decades, from S&MP management consoles to performance testing tools for multi-protocol, which is that same common interface that allows people to gain efficiencies by working in the same way across different systems. And that's an underappreciated way of saving labor. Not having to use a different tool for every single system that you touch allows you to gain efficiencies, and it allows you to become a master of a tool instead of a master of many tools.
Yeah, definitely agree with that. Yeah, a lot of organizations use tools quite often from the vendor. So if it's Oracle, they'll use Oracle Enterprise Manager, but if it's SQL Server, they'll use something else, SQL Management Studio, but those tools have absolutely nothing in common. So each one of them has a very steep learning curve. So I've been able to provide all of it in a common interface definitely helps.
I like the next one, which is easy to use. So I need that, right? Because if I'm going to mess with a profiler, and like you just said, if I've got 3 different databases and 3 different profilers to use, and then trying to compile that together with what I'm doing with load testing, I really don't want the hassle of having to learn something very detailed and different for each one. So being able to use a product like this, where it's there, the data's at your fingertips, and you can drill into it very quickly, I appreciate that. So it is a good interface, and you're actually going to show that in just a minute. I understand we've got a little demo that we're going to do. But you mentioned more about the detailed capture, that you're doing 1 second granularity. I'm really curious, though. We talked about getting that trend line. That's where I think these next 2 features come into play, right? Where we're getting snapshots and we're able to compare, so that if I do a load test, I can take a period of time from DBMarlin, all those statistics, and put them side by side and save this off, so I don't lose these. It's not like it was just a live picture. I can go back, okay, and I'm going to run another load test 2 weeks later and get that same snapshot and compare everything side by side, so I can see that. Can you talk more about that?
So snapshots is a relatively new thing we've just added, and it does exactly that. So you can save that data at the granularity and keep it for as long as you need. So you can always refer back to that. And saving the snapshots, you can either just do it manually through the user interface, but we also have an API, so you can integrate this into your load testing tools. So you could have your load testing tool automatically save a snapshot at the end of the load test, or you could have it automatically put a marker onto the timeline, so you could see when you're looking at your performance data when the load test started and when the load test completed, just using the API. And then as far as comparing these snapshots, we have something called our time comparison reports. So you can do this for any period of time, but it also works with snapshots. Now we've added snapshots into the product, so you could choose the first load test and the second load test, and when you click the button, then that will then do the analysis for you as to what the differences were between those two. So it looks at it starting from the top level. It'll look at host metrics like CPU, memory, disk I/O, but then it will look at instance level, how much time was spent in the database, what your average SQL response time was, and then as you go down the report, it gets more detailed all the way down to individual SQL statements, and you can see this statement was averaging 10 seconds in load test 1, and now it's taking 0.1 of a second because we've added an index. So it's a very good way of kind of validating that anything that you change between those 2 load tests has had the impact that you wanted it to do.
Let's talk a little bit about this demo that you've got set up for us. We're going to go to that in just a moment. Just set up the demo of what you're going to show us.
So that's just running a couple of load tests. I'm going to show the snapshotting feature that I just mentioned, and then I'm going to show the time comparison report as well, where you can just plug in those 2 snapshots and let it do the analysis for you.
Okay, let's go to that demo right now and we'll check it out.
I'm going to be using JMeter to generate some database load. Obviously, you can use your preferred tool. So in my JMeter test, what I have set up here is a thread pool which is going to connect to a SQL Server 2019 instance. We're going to run for a duration of 4 minutes with a 60-second ramp up, getting up to 30 virtual users. And what we can see here, we've just scanned through some of these statements, is that we've got a variety of different statements. We have some select statements across various tables. We also have some insert statements and some delete statements in here, just to give a nice balanced mix. So we can see here's the first load test that was already ran. And what I've done is I've used the save snapshots filter within DBMarlin. So save snapshots allow you to give a name and a description, and optionally keep the data for a time period of interest. So having done that, you can see now I can choose that from a drop-down list. I can pick my load test 1 with 30 virtual users, and by selecting that, I've now got my load test data at the 1 second granularity. You can see the ramp up there, and that's the complete test. And then we can start to analyze our top statements, any kind of wait events that the database is waiting on, and so on. So if we look at our top statements now, we can see the top statement here is this update statement, which has an average response time of 4 seconds. So if we click into that, you can see the statement comes from a batch. So if we have a look at the batch, we can then click into the batch to see the execution plan. So the execution plan gives us the steps that the SQL Server optimizer has to perform to execute this statement. And what we also have, if you look at the text here in green at the top, is a missing index suggestion. So SQL Server is actually recommending that we add an index in this case. So I'm going to try adding this index, and then let's see what the impact of that is in our next load test. So I'm just going to create the index that was suggested here. You can see that's now being done. Having run that. So if we go back to the instance level, change our time range, let's look at the last hour. So here we can see the load test again, and in a second we'll see the change marker that was added just here, and that was actually the index creation for the index that we just added there. So DBMarlin is keeping track of any schema changes that you make, and then you can see what the impact was on the performance. So let's go back to JMeter. We're going to kick off another test, having added that index, and let that run. So you can see it's running again now. Same number of virtual users. So we'll just let that run for a while, and then we'll come back and we'll save another snapshot and show how you can then compare that. So here's our completed load test. We can see our update statement is no longer the number 1 statement. It's actually dropped down to number 3 in the list, and its average response time is now 3 seconds rather than 4 seconds. Its weighted percentage is actually less than it was previously. So adding the index has made a positive benefit to our update statement in this case. What I'm going to do now is use our save snapshot feature again. So I'm going to name this as load test 2. Give it a description here. Find my index name, copy the index name. That was the index that I have added. So putting the description here then lets me compare it back. And I'm going to save the data again. That means the data doesn't get archived or purged, so we can reference back to this even several months down the line or even years down the line. We'll have this data until we choose to delete it. So now you can see we've got 2 different saved periods that we can actually choose between. So we can look at load test 2, we can look at load test 1. And where this becomes really useful is if we then plug these into the time comparison report. So rather than selecting the periods manually, you can actually just pick those 2 different load tests here. Obviously need to select the instance as well, SQL Server 2019 in this case, and now I can generate my report, and this gives me a side-by-side comparison of those 2 snapshots. So we can see that while the database time is roughly the same, the actual number of executions increased here. We're now doing over 9,000 executions compared to 7,000 previously. So same amount of time, we're getting more throughput as a result of that index change there. And we can see the individual effects on different statements within the test here.
Hey, that was a wonderful demo. Thanks, Mick, for showing us that. So if we wanted to find out more about DBMarlin, how would we do that?
So I think you have a slide with some next steps here. So yeah, either use the QR code or go to the website at the bottom. That's your special page, Scott.
Yeah,
So,
I have my own page there. So that QR code will take them to where?
To the URL there at the bottom. So that's the your special VIP page on our website for Friends of Scott Moore. But from there, you can then click through to download a free copy of the software. So we have the DBMarlin, the way it's licensed is it's a freemium model. So we have one free copy that you can use to monitor any database. And then if you want to monitor more than that, then obviously I'm happy to talk to you about purchasing more licenses.
I think DBMarlin is a great tool, and I know with James with QAC, QAC is also a partner with DBMarlin, and it's been used on a couple of engagements. I know I've used it on an engagement. What other potential uses can you see with this in the future for some of these engagements, James?
I think our use is only going to grow. I noticed that we found some interesting items the last time we used it, and we provided that feedback, I believe, to you, Mick. And you were able to do some things that actually improved the utility of DBMarlin over and above traditional profilers. We happen to notice that because of the way programmers were building queries, they were treating some queries as independent when they were all related, and we needed to do some roll-up capability for profiling purposes. And that is something that's going to set your tool apart from the in-house profilers from the vendors. So I can only see our use growing in that case. And so we're excited.
So that's the show today. I appreciate both of you being on the SMC Journal podcast. I will have links, including the QR code to everything that we showed today, how to get to your website, how to get to QA Consultant's website, how you find James. If you're needing a performance testing engagement and you're having database issues, they can definitely help you. Anything else that you guys want to say before we close the show today?
Just thanks for having us on again, Scott. It's been good to be on the podcast again.
And Jerry, I loved you in all those movies on the telethon.
Stay tuned. We've got more crazy stuff coming up. All right. Thanks for being on the show, guys. Talk to you soon. Okay, so what do you think about that? Or are you interested in profiling databases under load with the different relational types that we have? SQL Server, Oracle, MySQL, there's CockroachDB as well now in that mix. I'd like to hear your feedback. You can also talk to me through my website, through LinkedIn, through Twitter. You can also email me at help@scottmoore.consulting, and you can also subscribe to my YouTube channel. We would love to have you as part of that, so you'll be notified of this type of content when it becomes available. I would love to hear from you, love to hear your feedback about this show, as well as what other shows would you like to see, who else would you like to see interviewed, what are some topics that are of interest to you. Let me know. Love to hear from you. For today's show, this is Scott Moore and the SMC Journal podcast saying bye-bye.